This is your first look at SolidWorks simulation. With rescue equipment like this, performance is everything. The product must work reliably every time. SolidWorks contains a powerful set of tools we can use to test out the performance of a design in many different ways. Two key areas that concern most designers are function and strength. Let's look at how SolidWorks Motion and SolidWorks simulation tools can help us evaluate these goals. We've seen how we can assemble our design in SolidWorks, but how do we know it's going to function correctly? It's invaluable to be able to validate the spreader operation without the need to cut metal or build prototypes, like in the case of this sketch layout concept. With SolidWorks Motion, we can easily test our design during the early stages of development to aid in sizing parts, bearings, motors, and actuators to ensure they meet our design goals. As we go through and refine our design, we can continue to use motion to validate the function. Here we have a test fixture to determine the piston force required at different jaw openings to meet a minimum spreader force requirement. In SolidWorks Motion, we need only apply an actuator to drive the piston through its range of movement, the desired spreader force on both blocks, and finally specify that the tips of the jaws and the blocks will contact. An accurate physics engine then calculates the resulting motion, forces, velocities, and accelerations. We can look at a wealth of engineering data such as the bearing loads on the pins, how quickly parts are traveling, and so on. With the built-in plotting tool, we can quickly show the required piston force with respect to the open position. We're even able to check the strength of selected parts in the mechanism over the entire range of motion. This can really help in determining if we need to use SolidWorks simulation for a more in-depth analysis to ensure that part strengths meet our goals. Let's now focus in more detail on the structural aspects of our design with SolidWorks simulation. If we're concerned about parts failing, deflecting too much, or reducing weight, this is the tool for the job. Simulation can be used from the part level all the way up to the complete assembly to easily identify if the design will meet our needs. You set up the model just like you would when doing an experiment in the lab. We start by using fixtures to hold a part in place. We make selections just by picking on geometry. It couldn't be simpler. We then apply loads to test if our part is going to fail or deflect too much. Visual feedback on the screen makes it very easy to understand how we've set up our test. The checklist on the right-hand side makes sure that you have everything ready to test out your design's performance. After the simulation has run, you get immediate visual feedback on how the part is trying to deflect, which is great to confirm the test is set up correctly. It's easy to verify the factor of safety, stress, and deflection of the component. Simulation also allows you to look at many design variations very quickly with design studies. In this case, we want to optimize the pocket size to reduce the weight of the arms, but still ensure we meet the rigors of ripping open cars. The slider interface makes it incredibly easy to compare designs and find the right one to save the most weight. SolidWorks simulation also enables us to look at the entire design and understand how load is transferred between parts, as well as where the critical areas of the design are located. In this instance, we're looking at the loads through the entire spreader. A force has been applied to the hydraulic piston and the tips of the arms are being held in place. We're even able to slice through the model to look at any internal sections. Results update dynamically for immediate feedback. With SolidWorks simulation, you can even look at vibration, heat, material yield, durability, and many other types of tests. With SolidWorks Motion and SolidWorks simulation, you can test your designs before you build them, cutting down on prototypes, helping to make sure it will work the first time, and reduce the time it takes to reach production. This has been your first look at SolidWorks simulation. To learn more, contact your local SolidWorks reseller or explore our website for more information.